So we shall continue the discussion further, which we have been carrying out since last few sessions. Now, instead of circuit completion, we discussed about earthing, then carrying the wire to moon and so on. Now we make a small change. Instead of earthing, a big metallic sphere. I have brought two big metallic spheres. Big metallic sphere, what is the property it is having? Since it is big, it is having huge number of, what we can say, atoms, electrons, and being metallic, what will happen that if either an electron is pulled from that metal or pushed into that metal, number of electrons, they will get spread easily. So, since it gets spread easily, it will not create much opposition. Now, what we have done, the switch is not closed. What I will do, I will assemble, if such experiment is to be performed. So what we have got, a battery I have got. Almost all components in electric engineering are having two terminals. Right? So, constructing an experiment, what? A battery is there, a switch is there, lamp is there, and two metallic spheres are there. Is it okay? Suppose that now you start assembling the experiment. So what do you do? This you connect, right? Means this you connect here, this you connect here. This is wire only. That's all. This you connect here. So, do you think that something is going to happen? No, nothing is here hanging. Only bulb, sphere. Now, if you connect this, again nothing will happen because the switch is open. Nothing will happen, right? Is it okay? So what I can say? Battery, switch, lamp, sphere connections are they complete. Switch is off. And now if I connect this metallic sphere, what will happen? This point I will connect here. What will happen? Something will happen. Whether electrons will. What is the property of negative terminal of the battery? What is the property of negative terminal of the battery? To throw away electrons, flood electrons out. So will it start flooding? If I put an emitter here, if I will say that if I put a lamp here, will the lamp glow? The moment at which one more lamp I can have, I connect this. Negative terminal of battery, metallic sphere, I connect. What is the property of negative terminal of battery? To throw away electrons like a flood. So, whether this big metallic sphere, what is the meaning of big metallic sphere? It will not oppose because its area is too large, so no opposition, not much opposition. So, will electrons flow like this and this lamp glow? Yes or no? If yes, then it's fine, nothing to be explained further. If no, you have to explain why not. What if will lamp glow or not? No, lamp will not glow. Why it will not glow? So, right, so pump, listen very carefully, I am repeating it so many times. Pump and battery. Battery is see. On fluid and electric side there are many similarities. So, pump is a fluid pump or water pump. Like that, battery will be on electric side, battery is dash 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 pump. Fill in the blanks. What would be the answer? Water pump. Water pump does what? It pulls water from inlet, throws it from outlet. Like that, battery is pump of what? Electron pump, you can say, or charge pump. And if you want to be more precise, you should say electron pump. Only thing is that the potential and terminals are reverse. Why? Because electron is negative charge. So battery's negative terminal is the battery's positive terminal is supposed to be charge outlet, and battery's negative terminal should be supposed to be charge inlet if it is charge pump. But it is not, it is electron pump. When I say electron pump, then battery's negative terminal is electron outlet and battery's positive terminal is electron inlet, right? So even if I starting of a water pump does not guarantee me water coming out from the outlet. Why? The pump will be able to give water to the outlet provided that it is able to suck the same from inlet. If there is no feed at the inlet, pump is helpless. Is it right? Like that, even though I have connected this would be, that is the negative terminal of the battery will be able to flood away electrons, provide which electrons? Which it has fetched from positive terminal. Is it right? Since it is unable to fetch now, this lamp will not glow. Is it okay? But now if I close the switch, what will happen? Then what battery positive terminal tries to fetch. So it will fetch from where? From this metallic sphere. Why you say that the metallic sphere will allow electrons to be fetched from it? Why should you allow? If a robber comes and tries to forcefully fetch amount from you, do you allow? Then if there is a weak person, robber comes, what will happen? Robber will be able to snatch the amount. Why? Because opposition is less. Or, I am giving so many examples, you try to listen. You are at home. There is a bungalow, compound is there, and alongside the compound various trees are there. Trees are having some leaves, flowers, fruits. Suppose if a trespasser comes and takes away one leaf of one tree, what will happen? Will you prevent him? No. Why? Because there are abundant leaves. Is it right? So you will not like it. Suppose he takes one today, again comes and again tries to take that. Then what will you do? You are at home, you will shout. But याच्यासारखं सोपं उदाहरण कुठेही जगात तुम्हाला मिळणार नाही. You will shout. If you are sleeping in room and there is CCTV, you can see that. If once he takes, you will even ignore. If 2-3 takes, you will still be. If 2-3 he takes, you will get irritated. After some time, you will shout. After some time, you will shout. After some time, you will get up. Again, shout more. But you will not go because you feel that something is happening you are not liking. But you are not too up. You are opposed to it. You don't accept it now. First, you accept it. Later on, you are not accepting, but you are not damn opposed. So later on, then if it becomes too frequent, then you will get more. So more the leaves it steals, you will get, at some point of time, you will go and stand in front so that he can't. Like that. Metallic sphere is electrically neutral. What is the property of charge? To get distributed, it tries to pulled. So one, say, around 100 electrons are pulled from here. It doesn't happen. Those get spread across the sphere. So still the moment at which electrons are pulled away from sphere, there is a shortage of electrons on the sphere. Means the sphere gets positively charged. When it gets positively charged, later on, means when the local bogie is empty, you can easily enter in. As more people enter in, it tries to oppose more. Still people enter in. When they enter in, they become part of opposing more. But still few more enter in. And at one point of time, equilibrium happens. So, electron are pulled, initially no opposition, later on small opposition, but now you are there, thief is there. Thief tries to snatch amount from you. What will happen? If you are stronger, thief will go away. If thief is stronger, he will snatch something. So ultimately it happens on equilibrium. So this is opposing. This metallic sphere initially was reluctant. Either for means it is just like a normal student in the class. He is neither too much interested in going for lecture, nor is too much determined for bunking also. Okay, sometimes he may come in the class, sometimes he may not. So like that, this neutrality means what? No specific feeling. This sphere, this electron are taken out from this, okay. Electron are bombarded onto it, okay. But that initial reluctance or neutrality or don't care starts increasing, starts accumulating and gets built up in opposition, right? So after some time it will oppose. It opposes pulling. This what is happening here? Electron pulled, will throw here, it will grow. Come to this, throw away this, it will grow. Dump on. Means battery acting as electron pump is pulling electrons from this sphere and dumping them on this sphere. Then after some time, this sphere starts opposing pulling, this sphere starts opposing dumping. But batteries work is same, pull and dump. So after some time what will happen? Means initially there was some pull, no opposition. So flow will depend upon this voltage and this resistance. Right, but when opposition will start, the flow will reduce. So what will happen? The intensity of the lamp will suppose if the resistance of this lamp is say 10 ohms. So initially no opposition. No opposition means zero potential. No opposition means zero potential. So 10 amperes of current will flow initially. 100 volts, 10 amperes. And then it will start opposing. It will start opposing pulling, it will start opposing dumping. So as opposition is there, pull is constant. When it's common sense. When there was no opposition, this battery pull was forcing 10 amperes of current to flow. 10 amperes means 10 coulombs per second flowing through the cross section. Now as opposition is increased, battery is same, so naturally what is going to happen? Flow will reduce. So when flow reduces, but still direction of the flow is same. Flow reduces, what are you doing? Look here. Flow reduces, but direction of the flow is same. So direction of the flow being same, what will happen? The concentration of positive charge on this sphere will increase. Are you getting me? Or to be more precise, concentration of deficiency of electrons on this sphere means concentration of positive charge on this sphere will increase. Concentration of negative charge on this sphere will increase. As concentration increases, more opposition. But even though more opposition is there, still pull is in the same direction. So more concentration. So every time, at every instant, opposition will be more than the previous instant. So flow will be less than the previous instant and it will continue forever. Means the current initially which was 10 amperes will start exponentially reducing like this. But it will never reduce to zero ideally. Right? So these two spheres are performing the job of a capacitor. Is the idea clear? Then instead of spheres, we can have plates, large size plates. So this is capacitor. And now, when you talk of capacitor, current doesn't flow through capacitor. Charges, electrons are taken away from this and bombarded on this. So it creates positive charge here and negative charge here. So current doesn't means when the resistance, electrons flow through the resistance, but electrons never flow through the capacitance, they flow across, taken away and dumped on the other, right? So effectively, even if this is closed directly, lamp will continuously glow, circuit completion concept. If the separate like this, lamp will glow, intensity will come down. This is not closed path, circuit completion, but effectively like circuit completion, the lamp will reduce, intensity of lamp will reduce slowly and slowly. Is the idea clear? Or still any doubt is there? Last time we forgot one more thing. That was, I think, regarding accelerator, we left one thing in between. So when battery is connected, it's a simple circuit like this. I just am not recollecting whether we discussed or not. Why constant current flows through resistor? Attendance attendance. Why constant current flows through resistor? When I apply electromotive force, when electromotive force is applied, force is supposed to accelerate electrons. So if electrons are accelerated, if constant acceleration should lead to increase of speed, but it doesn't happen. Why? Because of what happens? The electrons, when they, just like when you travel on a vehicle on the road, because of friction, is opposition. Like that, when electrons travel through metal, they collide with the nuclei. And because of these collisions, means it is not a free flow. So its opposite is there. So depending upon the roughness of the road, depending upon what? Length of the wire, cross-sectional area of the wire, and resistivity of the wire, effective resistance is there. So less the resistance for same force, more current. More the resistance for same force, less current. Therefore, the concept of resistor, Ohm's law, leading to what you are doing? Hello, look here. The concept of Ohm's law for a constant voltage, constant resistor, constant current, even though voltage is a force, it does not result in acceleration of electrons, but it results in constant flow of electrons because of the opposition which the electrons encounter with the nuclei in between. Is it clear? So resistor, everything is clear now. Capacitor, almost everything is clear, not exactly. And voltage source. Voltage source is charge pump. Resistor is explained. And capacitor, now what will happen when it continues after some time? That means what will happen, that after some time almost the current will stop. Are you getting me? Means current will come down, means initially there was no opposition, the opposition starts increasing, and after some time current will almost stop. Means now this lamp we can remove, it just was no need. So I want effectively this point is A, this point is B. So effectively now what I have, this switch is closed. This is point A and this is point B, and after some time the current has stopped flowing. This is 100 volts. This switch is closed and lamp will stop glowing. Lamp will stop glowing. So this is not open. What kind of means now? What kind of device? What kind of entity you will put between A and B? What I do? Just I make a small change. I take just to give a feel. A and B. Now, what electric component you can see is as good as there, which has stopped the current. What you can think of? सुरुवातीला करंट होता, आता करंट थांबलाय. मग सर्किट मध्ये हा 100 व्होल्टचा सप्लाय आहे, हा स्विच जोडलेला आहे, हा 10 ओहमचा रेझिस्टर आहे. इथं काय जोडलं तर लॅम्प लागणार नाही, मोकळं सोडायचं नाही. You got the question? There is a 100 volt battery, lamp, switch on, point A and point B. What kind of thing which you put will result into the current not flowing? Anyone? काय पाहिजे? इथं कुठलं डिव्हाइस पाहिजे की जे लावलं तर करंट फ्लो होणार नाही?
हाय व्हॅल्यू ऑफ रेजिस्टन्स
किती आहे?
नेग्लिजिबल होणार पण होणार.
मोकळं सोडणं नाही, काही जोडायचं आहे आपल्याला. सम इलेक्ट्रिक डिव्हाइस which will result into zero flow.
So we can also connect positive charge metal plate.
नाही, मेटल प्लेट आता विषय काढा नको, कारण इथं त्या प्लेट सारखंच आहे. ते सोडून जे तुमच्या रोजच्या वापरातला आहे, विच यू नो रेजिस्टर, यू नो व्होल्टेज सोर्स, यू नो कॅपॅसिटर नको. आता कॅपॅसिटर करता आपण रिप्लेस करतोय.
So we can also connect same value voltage source.
In reverse means like this. Is it right? Is it right? So if I connect like this, it will result zero current. So two charged spheres behave like a belt. This is actually capacitor. So by drawing, we draw like this. So capacitor, voltage gets developed across the capacitor, and when the capacitor gets fully charged, it gets equal voltage. So you get 10 volts after full charge. So when it gets 10 volts, By what virtue it gets 10 volts? Why it starts opposing and opposes equal to the pulling? Because it gets charged. It gets charged means what? This is plate B. This is plate A. No, उलटे हो गया. ह्याला A होईल. असं काय? फार फरक पडत नाही पण असू दे. A and B. So plate A and plate B. So how much charge? How much charge will result into this voltage if the plate is big? The plate is big and plate is small. Give common sense answer. If the plates are too big, the lamp will glow for less time or more time. If the huge plates and narrow plates, small size plates, large size plates. If the large size plates, what the plates do? When electrons are pulled away from one plate and dumped on the other plate, the electrons are pulled away from plate A and those are dumped on plate B. So plate A starts becoming positively charged and plate B starts becoming negatively charged, right? And because of that they start opposing. Means when the plates get charged, effectively voltage is developed across the capacitor. And after some time, the developed voltage will be as good as input voltage and flow will stop. So if the plates are big and if the plates are small, when the voltage across plates will reach to input voltage, if plates are big, will it reach early or will it reach late? If plates are small, will it reach early, will it reach late, or it doesn't depend on the size of the plates. मोठ्या प्लेट्स असतील तर लवकर लॅम्प विझेल का उशिरा विझेल? लहान प्लेट असतील काय होईल का प्लेट्स मोठ्या केल्यानं काय काही फरक पडणार नाही. Distance between plates. So he raised one more point. That is also right. For same distance, bigger plates will keep the lamp glowing for longer time. That's right. Because the plate being big, it will.
पण व्हॉल्यूम समजा आपण कॉन्स्टंट ठेवलं तर मग तेवढ्याच टाइम पर्यंत.
Which volume?
ते प्लेटचं व्हॉल्यूम.
So he said a very important point, but volume is not a major point here. Why? मगाशी मी स्फिअर तुम्हाला एक स्फिअर का सांगितलं? अर्थ मून एक्झाम्पल पण स्फिअर सांगितलं, पण स्फिअरला मिनिंग नाही आहे का? ऍक्च्युअली द चार्जेस गेट ते लांब जातात तेव्हा ते आत थांबत ते गेट डिस्ट्रीब्युटेड सरफेस. व्हॉल्यूम इज इमटेरियल. So sphere is a plate bundle. So I changed from to plate. More bigger the plate, obviously. Why plate will start opposing the movement? Basically, when electrons are pulled from this plate, why it will start opposing? Because again same question. When electrons are taken away, समजा मी तुमच्याकडे पैसे काढून घ्यायला लागलो, तुम्ही काय करणार? तुम्हाला माझे पैसे आहे. सिमिलरली पण समजा मी तुमच्या घरात माती न्यायला लागलो, कदाचित तेवढं विरोध करणार नाही. आता इथून when I am pulling away electrons, why it oppose? When they are pulled away, it results into positive charge, and because of that it starts opposing. But the density of the charge will depend on, means if I remove 1000 electrons from a very big plate and a very small plate, what will happen? if I remove 1000 electrons from a very big plate and very small plate. Initially, there was no opposition. When I remove 1000 from both plates, which plate will start opposing more? Smaller plate, because smaller plate, for smaller plate, removal of 100,000, suppose if that 1000 rupees are stolen, a rich person will not matter, but not so rich person will find it, what we can say, something which she needs to worry about. Is it right? So for big plate, 1000 liters, okay, not much opposition. For small plate, so what happens is that, my question is, how much charge? Opposition means effectively opposing battery. Means effectively capacitor, when charged, starts acting as a battery. A charged capacitor starts acting as a battery whose voltage depends upon size of the plates. Effectively, when I remove some electrons, so electrons removed from this, so this is charged by plus Q and those are dumped here, so charged by minus Q. So a top plate or one plate plus Q charge, other plate minus Q charge, it is said that the capacitor is having a charge, not 2Q. A capacitor charged with Q means plus Q on one plate and minus Q on other plate. So this will result into different voltage depending upon size of the capacitor. Removal of some charge from one plate and removal of some electrons from top plate and transferring the same on bottom plate will make the capacitor charge with charge Q. That Q, if it is made up of smaller plates, it will oppose more, and if it is made of larger plates, it will oppose less. So effectively, size of the plates and distance between the plates, and what is you have put in the dielectric constant. So epsilon A and D. So effectively, you get a capacitance concept. So for what charge, what voltage effectively would be, means a charged capacitor starts opposing like a battery. For what charge it opposes, by which voltage level battery depends upon the capacitance, and what is the formula which you know. Only thing is that I try to explain it. Q is equal to C into, but a small, capital small is not so much. Q equal to CV, or V is equal to Q by C. V is equal to by C, right? So now with this everything, what is voltage? Right now we continue pseudo understanding of voltage. म्हणजे voltage काही इतकं कळलेलं नाही आपल्याला, पण असू दे आता. Voltage you know. Let us say that we know. Current you know. What is current? Number of charges moving across a cross section in given time. Charge. So charge you know, voltage you know, current you know. For resistor, what is the formula? I is equal to Q by R. And for capacitor, what is the formula? Q equal to C is the formula for capacitor. I is equal to V by R is the formula for resistor. Now with this, without giving any further hint, the example of water level is given to you. You now tell me what happened. One volt voltage, value सोपे घेतलं. 1 ohm resistance, 1 farad capacitance. Switch S. And voltage across this is derive the expression for VOT if switch S is closed at t equal to 0 and initially capacitor was discharged. Discharge कसा करायचा? दोन्ही पे शॉर्ट करायचा आणि सेगमेंट टाकायचा. Derive. It's very important question and few of you must be able to derive it completely without any hint now. Because if I give the hint, it will reduce your curiosity. Formulas are given. V equal to IR, Q equal to CV, R is 1, C is 1. And what is the relation between Q and I? I and Q. What is the relation? I equal to dQ by dt. Right? Is it okay? So it is a series circuit. So current through resistor and current through capacitor are same. What is current through resistor? V by what is V by? So now we can start. Very simple. I can draw the circuit. Switch is closed. This is 1 volt. Switch is closed, 1 ohm. This is VOT, right? So for resistor, what is voltage? 1 minus VOT. And this current is I, right? So for resistor, IT is equal to voltage across resistor upon resistance. What voltage across resistance? Voltage 1 volt and minus VOT, right? 1 minus VOT upon 1. Is it right? Everybody agrees? So IT is equal to 1 minus VOT. And for capacitor, what is IT? IT is same, dQ by dt, right? So IT is equal to, for capacitor IT is dQ by dt, right? IT is equal to dQ, the dQt multiplier, because Q is also function of time changing, right? But for capacitor, what is Q? C into C constant time into Vt, right? What is Vt? What is voltage? This same as VOT, right? Capacitive voltage plus capacitive we are taking output voltage. So everybody agrees that Qt is equal to C into VOT. C is constant, so C must come out, and C is किती घेतला आपण मुद्दा 1 farad. So do you agree that IT is equal to C dVOT by dt, C being 1. This is equation 1. This is equation 2. It being a series circuit, both currents must be same. It is actually IRT, it is ICT, but for series circuit, IRT equal to ICT equal to IT. So these must be same. So 1 minus VOT, or I can write this dVOT by dt is equal to 1 minus VOT. VOT I can take on this side. So what is the answer now? dVOT by dt plus VOT is equal to 1 is a differential equation. And VO0 is, because it is said that the capacitor is discharged. So dVOT by dt plus VOT equal to 1 and VO0 equal to 0 is the differential equation which should give me the answer.
1 minus e raised to minus 2.
That we have already discussed that in case of their water level issue, right? Or those again who have not understood that time, for all such kinds of differential, these are called as linear differential equations of first order. For linear differential equations of first order, the solution is always a plus b e raised to lambda t. Right? What are you doing? Look here. A plus, even if by ensuring that you look at the whiteboard, I can't enforce concentration, but let us, by ensuring that you look at the whiteboard, I reduce the probability of distraction. I will not say that I enforce concentration, but reducing probability of distraction will enable more concentration. So dVOT by dt plus VOT is equal to 1. And always differential equation without initial condition is incomplete statement. We assume that solution for this is VOT is equal to a plus b e raised to lambda t. Right? But this is given. So you can solve this first by differentiating this. But before that, you can make this condition used so as to make it simple. So at t equal to 0, so at t equal to 0, VO0 is equal to A plus at t equal to 0, this becomes 0. This becomes 0, so it becomes 1 plus B, that is equal to 0. That is B is equal to minus E. So rather than starting with this solution, the special case solution for the given initial condition is VOT is equal to A minus A e raised to lambda t. Then when VOT is A e raised to A minus lambda t, what is dVOT by dt? We can differentiate it. That is minus A lambda or minus lambda A e raised to lambda t, right? This plus VOT is equal to 1. So this A we can write minus lambda A e raised to lambda t plus A minus A e raised to lambda t is equal to 1. Right? So what we can have simply A minus into bracket so there are two ways. Put t equal to 0, get one equality. Put t equal to minus infinity, put other equality. When you put t equal to 0, this becomes 1. So one case you get. And when you put t equal to minus infinity, this term goes. Or simple words, have it into two parts. Terms without e raised to lambda t, terms with e raised to lambda t. Terms without e raised to lambda t, a equal to 1. So a equal to 1. Then terms without e raised to lambda t, minus a 1 plus lambda, and on the other side there is no term, so 0, right? So this is, so lambda equal to, so with lambda equal to minus 1, a equal to 1, VOT is equal to A minus A, that 1 e raised to, is it right? This is the answer. Is it okay? So, very simple one. I explained it to the most simplest extent possible. We continue tomorrow.